Hello and welcome. Let's continue with this series of SAR for Etodolac. So Etodolac is an NSAID. It's a preferential COX-2 inhibitor. Preferential means that it prefers to inhibit COX-2, but it can also inhibit COX-1. So the COX-1 activity is less compared to COX-2 activity. Now let's look at the SAR. So this structure is what we call a pyrano carboxylic acid derivative because it has a pyrene ring at this position. A pyrene ring is a benzene ring with an oxygen atom. When you number this structure, we can number this as 1, 2, 3, 4, and up to this number 9. If we want to discuss SAR, we can number these as R1, this as R2, and this as R3. Now, we say that the acid center for any NSAID is very important for activity. So, the acid center in this case is an acetic acid derivative. Now, at this position, if you decide to add, let's say, an amide or an ester, if we decide to lengthen this chain, then it corresponds to a decrease in activity. At the same time, if you try to introduce a methyl here, what we call an alpha methyl, it also corresponds to a decrease in activity. In fact, there is no activity at all. It abolishes activity. Yes. At this position R1 is also very important because at position R1, when we lengthen this side chain by introducing maybe an ethyl or a propyl, we make a compound that has higher potency compared to when this is only a methyl. So an ethyl or a propyl is about 20 times more potent when this compound is just an ethyl. Yes, a propyl is 20 times more potent when this compound is an ethyl. Again, at position R3, at this position at number 8 is also very crucial for activity. When you introduce substitutes in the 8th position in position number 8, it corresponds to an increase in activity. Specific examples include maybe groups such as methyl or groups such as maybe fluoromethyl or ethyl or even N-propyl substituents corresponded with an increase in activity. This is called a pyrrole ring. It's also very important for activity because it's the nucleus, is the core structure for Etodolac. Yes. Yes, at R1 we say the presence of the hydrocarbon chain is very essential for activity. So the hydrocarbon chain at R1 is very essential for activity. And you've said that the acid center here is very important for anti-inflammatory activity. If you lengthen this chain, you decrease the activity of the compound, it becomes inactive. If you add an alpha methyl at this position, if you add an alpha methyl here, it also corresponds by giving an inactive compound. Until then, peace.